Hello viewers, my name is Kuldeep Singh. Welcome to my YouTube channel Technical Skills. Guys, if you are new to this channel, please subscribe this channel and please do hit the bell icon for latest updates. Hello viewers, if any one of you is interested in taking online or offline training, you can contact me on the number given on screen. You can call me or you can send me a WhatsApp message. Also, you can check my number in description of video. Thank you very much.
Hello viewers, welcome again to this new PLC tutorial session. In this session, we will start a new topic, that is counters. So what are the counters? Counters are basically instruction in a PLC that is used to count a particular thing. Suppose you want to count number of bottles, number of boxes, or anything, number of packets. So we use counters to count the thing. Okay. So basically there are two types of counters in PLC. First is CTU, that is counter up, that counts upwards, means 1, 2, 3 increment way. Okay. Second is CTD, that is counter down. This counter counts downwards like 10, 9, 8, 7, 6, 5, reverse counting. Okay. And the up counter counts forward like 1, 2, 3, 4, and down counter counts reverse like 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, like twice. Okay. And this is the address for the counter in Allen Bradley PLC, that is file type, file name, column, counter number. So C is the file type, like for the timer we use T for the timer, for counter we use C. C5 colon 0, 0 is the counter number, this is the first counter. Second is C5 colon 1, then 2, 3, likewise. Okay, so this will go on till the number of counters available in the PLC. Next is, this is a pictorial presentation of counter. So this is counter up. So you can see the counter up here. This is a counter, and this is the addressing C5 colon 0. This is a count up, so it is written CTU, and this is the preset, number of preset you can put over here, and this is the accumulator, the counting will show here. Okay, and this is CU, count up bit, and this is a DN, that is a done bit. Okay, and the next is counter down. So this is the CTD counter down, it counts downwards. So here you have to write the addressing, then the preset, then the accumulator. Similar way, it also has a done bit, and this is the countdown bit in counter down. In up counter it is a CU, and in down counter it is a CD. Okay, so this is the basic difference between CTU and CTD. And the next is the number of bits available in counter. So the basic is the done bit that is available. There is no TT bit available in the counter. So done bit is when accum is greater than equal to preset. The done bit will get on only when the accumulator of the counter will goes count up to preset, or it goes up greater than also. So addressing is C5 colon 0 slash dn. 0 means for the count number 0. If you have a counter number 1, you have to write C5 colon 1 slash dn. So this is the basic about the counter. So let's go and start with the program. Okay, so let's see. So this is the input, and we have to take a, suppose I take a CTU counter up. So here is the addressing counter up C5 colon 0, and let's say I put it 5 over here. Okay, so now I have to take a done bit like a T on timer. So this is the done bit C5 colon 0 slash dn. I'm taking it 0 because the counter number is 0 here, and output O0 colon 0. This is the output. Okay, let's see how it works. So I have to, when I force on and force off, I'm giving a pulse to the counter. See, you can see CU gets on. C always gets on whenever it gets the pulse from the input. Okay, force off, CU gets off. So when I force and force off one time, this accumulator gets on for one time. So it gets accumulator here. Okay, so it increments to 1. When I again force on and force off, it increments to 2. Likewise, it gets on incrementing again and again the number of time I am giving pulses or I am getting this input on and off. Okay, see the accumulator 4. Now when I press it, it gets 5. When accum is greater than or equal to preset, the done bit gets on. Okay, if I still get it on, the accumulator will count. Okay, but the done bit will remain on. Okay, so this is, you can see output is on. But now how to this stop this output, or how to reset the counter? To reset the counter, you have to take a reset like I have told you in RTU. Okay, so this is the reset. You have to give this addressing of counter over here. You have to take input, another input over here, or like 1. Now when I, let's do it again, force on, force off. So I have to do it 5 times again, at least 5 times, so that I can get a output from the done bit. Now I got the output. Now when I press this input, you can see counter gets reset. So this is how the CTU counter up works. Okay, so now let's move to counter down, CTD. Okay, so you can take a counter down over here like this. Okay, or you can change it over here also. Okay, let's change it from here, CTD. Okay, now let's say this is the preset, and if I just download it like this only, so what happens when I force on this input? See, CD gets on, but now accum is counting downwards from the 0, because accum was 0. When I press, it is going back. Okay, so what I have to do is, what I have to do is, so it is counting downwards from accumulator. So what I have to do is, I have to set the accum value so that it counts downwards from that value. So I am putting it like 5 over here. Okay, so when I downloaded it, see, done bit is on because accum is greater than preset. So when I force on it, it is getting down. 4, 3, as it goes down from preset, it gets off. Okay, so it will go down till I keep on pressing this input. Okay, and it will go negative also. Okay, you can see. Now if I reset this, reset means when I force on, it will make this accum again 0. So this is not the value that I have put in starting. So to get that again value again, I can't use this reset. Okay, so what I have to do is, I have to do take another instruction if I want to reset this, and I have to get this 5 again. So what I will do, I will take a instruction move logic. This is a move command. So this is a command where it what this command is doing is just it is moving a value from source to destination. So source is what is the value, or from where the value is moving. Okay, let's see, let's say that source is 5, so my value is 5, that is a constant value, and I have to move it in counter. Okay, whenever I place this input, this 5 will move to this counter. So I will write This is the counter address, but where I have to move it is in reset or accum. If I have to move it in accum, I will give accumulator IACC. So whenever I press this input, this 5 will move to the accumulator, and this counter down will get reset. Okay, let's check. See, now 5 accum is 5, reset is 3, accum is greater than preset. So when I force on this, it will count downwards 3, 2, as it goes down again and again. Okay, now if I press this input, this move command will, what will this command will do, this will move this 5 value to this accumulator. See, you can see this is, I got 5 or 5 over here. So this is the how we can use this move command in counters. Okay, next is what I have to do is I can use a compare command with the counters. So let's check how we can use a compare command with counters. Okay, let's use CTU only. Okay, now here is a compare command. So let's, this is a equal, this is not equal. Okay, and this C5 colon 0 dot ACC. Okay, so I have given a this accumulator value, so I can compare these two values. Okay, so I am comparing with a constraint. Okay, so source A, source B. What this command is doing is equal command is doing that if source A is equal to source B, then it will pass on the supply, and if I take output over here, sorry, will take output over here, it will switch on this output. Okay, so this output will get on when this accumulator sorry, this source is equal to source B. So I have taken a source B, source is at the value of accumulator. It will keep on changing, so it will come over here, and I have taken a constant over here. I can also take a variable if I want to compare a variable. Okay, so let's say I have taken this not equal also, so I will take suppose 2 over here, and I can take a output. So what this not equal to will do is that whenever these two values are not equal, then only it will pass on the supply. Likewise, I have some compare commands like less than, uh, greater than. Okay, and this is less than equal to, greater than equal to. So these all commands work like the same. When this A is less than B and source A value is less than B, then only it will pass on the supply. In greater command, when A is greater than B, then it will pass on the supply. In less than equal to command, when A is less than equal to B, then it will pass on the supply. When this A is greater than equal to B, then only pass on the supply. Okay, so let's take output. Okay, over here. So this is the output, and let's compare. I'm comparing this accumulator only right now. Okay, I'm taking a random value. Okay, you can take any value, but when you do the questions, you do the programming, it will be according to the condition. So I have taken output in series with all these compare instructions. Now let's check how it works. Okay, so you can see this is the first command equal to C5 colon 00 dot ACC. So it is 0 showing over here because in accumulator we have a 0. It is showing 0. And I have taken a constant value 1. So when it is comparing this 0 with the 1, you can see that it is not equal. So output is off. Okay. When we go down to not equal to, you can see 0 is not equal to 2. So condition is true because this is a compare block of not equal to. So it will only see that A is not equal to B, then only it will pass on the supply. So it is passing the supply. You can see output is on. Next command is less command. This is, see, you can see 0 is less than 3. The condition is true because this is the less command. If A is less than B, then only it will pass on the supply, so output is getting on. Next is greater command. If A is greater than B only, then only it will pass on the supply, but A is less than B, you can see, so output is false, so output is off. So condition is false, output is off. Now you can similarly check LEQ and GEQ. LEQ supplies on because it is less than, GEQ supplies off because it is greater than. It is not greater than. Okay. So if I force on this, condition get changed. You can see now IQ is 1. So this 1 will be get compared again and again. 1 is equal to 1, output is on. Here 1 is not equal to 2, output is off. 1 is less than 3, output is on. So likewise, if you keeps on pressing, the conditions will change every time. Now it is 2, 2 is not equal to 1, output is off. 2 is equal to 2, so it is not equal to block, output is off. 2 is less than 3, output is on. Okay. Likewise, you can check, you can practice this with different numbers. Okay, you can see now this is on because 3 is not equal to 2, 3 is less than 1, 3 is not less than 3, so it is off. Okay, so this is the compare command. You can check, you have to practice, you can do this, you can do this, and you can check whether it is working properly or not. You can see greater than equal to command is working, less than equal to also working, greater than is working but less than is not working. Okay, so this is the compare instructions you can use with the counters. For today's session, this much will be there. Thank you very much. Keep practicing, keep learning.
Hello viewers, if any one of you is interested in taking online or offline training, you can contact me on the number given on screen. You can call me or you can send me a WhatsApp message. Also you can check my number in description of video. Thank you very much. Thank you very much for watching this video. Please subscribe this channel. Also hit the bell icon for latest updates. Please give this video thumbs up and do share it with your friends. Also please comment below how do you like this video. If you have any questions, please comment below. I will definitely answer your questions. Thank you very much.